Dimensional analysis, travel. This is a good one that's a lot more tangible for a lot more people if you're not interested in things like sports or time. So number one, Mars is closest to Earth at 75,300,000 kilometers. The average speed of manned space travel is 39,000 kilometers per hour. How many days would it take to reach our red planet there? So I put here our rates. The formula for dimensional analysis. So remember, it's given over 1 multiplied by the rate where the desired unit goes on top, and the one that you're trying to cancel out from the given goes on the bottom. This is always what's going to guide you. The given unit on top here should always be canceled out by the unit that's listed there. Okay, so let's get rid of all this and start putting in some real numbers here. We see here that our given that we need to identify here is going to be right here because it's not attached to a per, or it's not telling you that for, every time you go this distance you're going to get so and so amount of something completely different. So that tells us that that's our given unit. So we can actually write that. That's going to be big number, 75,300,000 kilometers over 1. The reason your teachers in chemistry always yelled at you about units is because this is what guides us. So it's not just a matter of trying to make your teacher happy. It's a matter of allowing yourself to know where to go next, because we see kilometers is here in the numerator. So that tells us that kilometers needs to be in this denominator. And lo and behold, we have a rate that's been given to us in this question, 39,000 kilometers per hour. This is the rate of like the Apollo mission back in the 60s, so I'm pretty sure they travel faster than this, but I just, as a space nerd, I had to make sure I said that. All right, it's 39,000 kilometers for every 1 hour. And what we see is that kilometers cancels out, and we now have hours, but they're not asking for hours, they're asking for days. So we have one more rate that we need to put in, right, where we're going to see that hours is going to be on the denominator, so it can cancel out here. And we need to put something that's true, right? Something that we know, and that is that 1 hour is going to be, I'm sorry. So, I'm sorry, it's 24 hours. It's going to be how many hours are in 1 day. So since we can make that connection, we see hours is still canceled out. This is true after 24 hours has passed, so is a day and vice versa. And we now have reached our desired unit, which is day. And that's what they're asking us to solve for, days. All right, then we just multiply our numerators, and we're left with 75,300,000 over our denominators after those have been multiplied. So let's go ahead and put that in, 39,000 multiplied by 24, and that gives us 936,000, and it is our units that are left over is days. So what we do is remember that we just divide our numerator 75,300,000, 1, 2, 3, nice, divided by 936, 1, 2, 3, and what we end up with is about 80.4 days, and this is not really how long it takes. It actually takes much longer, but this is just an ideal situation, and maybe one day we'll get to Mars in 80 days or something like that. So that is a good example of you seeing the denominator change on us. Let's go ahead and take it on number 2. The top speed of a Ferrari 458 is 320 kilometers per hour. How many feet would this car travel after 15 minutes? So this is like a bunch of different units that are mixing up, which is always going to confuse students, so I want to make sure I included this. Okay, so 15 minutes is our given. So we're going to say 15 minutes over 1. And then we see that they're asking how many feet would it travel. What we see is that, well, this is given to us, this rate that we're given is 458 it's 320 kilometers per hour. This is the name of the car, so that's not a number I should be reading really. 320 kilometers per hour. So we need to write a rate that's going to allow us to start setting up for this. And we see is that our unit that they give us is hours, but we're not even close to that, right? So let's start turning minutes into hours. And what we know is that 60 minutes, let me put this in red, 60 minutes, right? We have to use minutes because it's canceling out with this denominator here is in 1 hour. All right, great. This is great. So now what we see is that hours is our unit on top. We can now use this rate that's given to us in the question where we see that for every 1 hour that passes, this car is traveling 320 kilometers. That's all these fractions are. All right, hidden division problems, but they're also telling us rates. They're also giving us rates. That's what makes this so confusing for a lot of students, is that these fractions represent numerous different things. So it's always good to pause the video and kind of like look and analyze to see what these are representing. All right. So how many feet would this car travel? Well, you know, we finally got to the distance, which is kilometers, but it's not the unit that they're looking for. And what we can say is that there is 1 kilometer is 1,000 meters. And then all you have to do is find out how many meters are in, how many feet are in a meter. And according to Siri, 1 meter is going to give us 3.28 feet. All right, and then let's keep track of our units here, since I forgot to do that in the last few steps. Kilometers, kilometers, meters, meters. And here we are, we're left with the unit that we are ultimately trying to solve for, which is feet, which is what they ask us to solve for, how many feet. So we're going to multiply all our numerators and put it over our denominator after we've finished multiplying all that. So let's start scratch here. It's going to be 15 times 1 times 320. Now some people feel like it's weird to multiply by 1, and you don't necessarily have to. It's just to let you all know the steps that I'm taking, so kind of be consistent. 3.28. All right, and what we're left with is this crazy huge number. Let me rewrite this here. Let me get rid of this so I can have more space. And then our numerator is 15,744, 15,744, 00. And that's going to go over 1 times 60 times 1 times 1 times 1, so over 60. And we take our numerator here. We'll just divide it by 60. It happens to be very convenient in this case. And we're left with 262, 400, 262, 400 feet. All right, let's get to this last one here. All right, Usain Bolt reached a top speed of 28 miles per hour. That's crazy. In the 2010 Olympics, how many inches would he travel if he kept this speed for 20 minutes? Which would be impossible based on current human conditions, maybe in the future when they have like crazy science or something like that. So our given here is 20 minutes. It's not attached to anything. You see here, this is 28 miles per hour. 2010 Olympics, we're not going to use that. So 20 minutes is going to be our given here. So 20 minutes over 1. All right, and we see that his speed is given to us in miles per hour, so we can't keep minutes on the board here. So we're going to do what we did earlier there, and that's turn minutes into hours. And what we know is that 1 hour is 60 minutes. Let me make that look a little bit more clear. 60 minutes. And then we can multiply these here. And we cancel out what we see here, minutes and minutes. And we know that our next fraction is going to have hours in the denominator, because ultimately we're trying to figure out inches, right? So we see here that they give us 28 miles for every 1 hour that passes. All right, so there we are. We're a unit on top. It's measuring distance, miles, so that tells us that we're close, but we're not as close as we want to be. All right, so what we can do is we can see our next rate, which will be, I can ask Siri straight up how many feet are in a mile. I mean, how many inches are in a mile, but I'd rather just go with feet, just so it's a little bit more tangible from where we're going. All right, so let's see how many feet are per mile. All right, how many feet are in a mile?
I couldn't find any.
How many feet are in a mile?
5,280 feet.
Good old Siri. 5280. Sometimes you have to ask her twice, but she gets it. All right, and then we can now say with feet and the denominators here so that it cancels out. Let's actually let's do a recount on our units. This cancels, that cancels, that cancels. And we know that we need to get it into inches, and what we know is that 1 foot is 12 inches. All right, and then now let's create our final fraction, which is going to be the result of 20 times 1 times 28 times 5280 times 12. I'm going to have a crazy numerator. These crazy numerators just keep coming up. 35,481, 600, all over 1 times 60 times 1 times 1 times 1, which is going to be 60. So once again, we take this number, we clear it all out, and we end up with 35,481, 600 divided by 60, and we're left with 59, 360 inches.